So one of the absolute legends in the AI field, Andrej Karpathy, had a tweet recently that I want to talk about today. He talks about various different phases of training and teaching LLMs. We start with the pre-training phase, where we quite literally throw the entire internet, books, PDFs, research at LLMs, and we teach them patterns within natural language. These models like GPT-4 and non-thinking models become really good at pattern matching, but they fail when it comes to more complex reasoning and planning type tasks. Then came the breakthrough with the chain of thought, where we showed models chain of thought, step-by-step reasoning to go from a query or a problem to the answer. And we got thousands of people in a supervised way breaking down problems into steps, and we used that information to teach LLMs how to think step by step in a chain of thought manner. That gave us models like O1 or O3 and all the various different thinking models. Reinforcement learning was another unlocking factor, where we were able to use rewards to teach LLMs how to think and navigate through various different domains. This became an extraordinarily important tool both from an agentic point of view and also in LLMs to really fine-tune and drive their behavior into a particular way that we're interested in. But now we're in this phase of post-training or test time fine-tuning and optimization. And there are two distinct domains that we are really pushing. One is test time fine-tuning, where we actually update the weights of the model based on examples at test time. So when a new query comes in, we actually identify what is the type of query, and then we find examples and fine-tune the model based on that. And the second one, which he talks about being potentially the most optimal and promising, is context optimization. So this is kind of similar to prompt engineering or prompt optimization, but the idea is that LLMs really work from the context that they're given. And so what we want to do is we want to optimize within the token space. So not touch the weights, but actually optimize within the token space. And talk about the idea of how we can rearrange these tokens within the context to arrive at the optimal behavior of the LLM. What I find interesting is that we're taking a core technology, which is transformers that are building our base language models, and we're adding all these different layers, chain of thought, reinforcement learning, token optimization, fine-tuning, to make these LLMs more and more capable.